In March of recent years, reports surrounding the aftermath of the Chernobyl disaster have unearthed new insights, adding layers to our understanding of one of the most catastrophic nuclear incidents in history. Occurring on April 26, 1986, at the Chernobyl nuclear power plant in the then Soviet Union, now present-day Ukraine, the incident released massive amounts of radioactive materials into the environment. The affected areas, primarily Ukraine, Belarus, and Russia, continue to witness the lingering effects of this disaster over 3 decades later. In the last decade, studies have focused on the persistence of radioactive contamination and its implications on both the environment and human health. Recent reports indicate that over 2,600 square kilometers of land remain uninhabitable due to high radiation levels, creating a ghostly exclusion zone around Chernobyl. While nature appears to have reclaimed the landscape, these reports also illuminate the silent resilience of flora and fauna that have adapted, surprisingly thriving in the contaminated area. Trees, plants, and wildlife like wolves and bears have formed a unique ecosystem, thriving in the absence of humans, yet challenges persist as scientists continue to monitor genetic mutations and long-term ecological impacts. On the human front, the legacy of Chernobyl reverberates through the affected populations. Health reports continue to highlight the increased rates of thyroid cancer, particularly among those exposed as children in the immediate aftermath. International health organizations have observed not only physical maladies, but also significant psychological distress among survivors and evacuees. Each March, studies revisit these impacts, seeking to improve our understanding of radiation's prolonged health effects. Although thyroid cancer is a major concern, some reports suggest that with early detection and treatment, recovery rates are promisingly high. Efforts to contain and mitigate the disaster's aftermath are continuously underway. Notably, the construction of the new safe confinement structure, completed in 2016, aimed to contain the radioactive remains of the reactor. However, recent evaluations suggest that while it has considerably reduced radiation emissions, it is a temporary solution with an expected lifespan of 100 years. The ongoing challenge is to develop sustainable long-term strategies to dismantle the reactor and safely store nuclear waste. This requires continuous innovation and international cooperation, ensuring that the lessons of Chernobyl inform future nuclear safety standards globally. The reports also emphasize the enduring human spirit and dedication to understanding and overcoming the disaster's consequences. Scientists, international agencies, and governments collaborate to manage and learn from this monumental accident. Educational programs and commemorative activities in neighboring regions remind us of the fortitude of those who sacrificed their safety, including the liquidators who bravely contained the initial fallout. In conclusion, the insights from the March reports highlight both the immense and complex legacy of Chernobyl. It is a testament to nature's resilience and the collective human endeavor to learn, adapt, and move forward. As science continues to unravel the intricacies of nuclear disaster management, Chernobyl remains a powerful reminder of the potential perils of technological advancement and the vital importance of vigilance, safety, and responsibility. The path from Chernobyl stretches into the future, carrying with it the hopes for a safer world.